tutorial. So I was in the Max Discord today and somebody asked a pretty interesting question about how to do something very specific in Ableton Live using Max for Live device that I felt was a really good way to get into the concept of using the Live API and interacting with Ableton Live from Max for Live. So we'll go through that, we'll do what this person was trying to do, and use that as an opportunity to learn. So here's what the person was trying to do. They want it to be so that when they press different keys on their MIDI keyboard, it mutes and unmutes tracks in Ableton. And they want it to be so that the track is muted by default, and when they hold down the key on their MIDI keyboard, it unmutes the track, and then when they release it, it mutes it again. They know it's possible with Max, but they don't know how, so we'll teach them. Okay, so the first thing that we're going to do is we have a MIDI track here, which is simply responsible for handling this situation. So that's all this MIDI track does, and we're going to put a Max MIDI effect in it. And this MIDI effect, what we're going to build is something that is aware of all these tracks that exist in the live set, that is capable of receiving MIDI notes, and is able to basically use the note value of those MIDI notes to map to all the different tracks in the live set, and then use the velocity value to mute and unmute the track. So I have my push here connected to this MIDI track, and you can see that when I press the pads on it, I get MIDI notes. And you can see I get two events. The first one is what's called the note on event. So it has a velocity value here that is non-zero. And then when I release the key, I get a 0. And depending on which pad I press, I get a different value here in the left column. So we're basically going to say, let's say C1 is the lower left-hand corner pad on my push. We'll say that's going to be associated with the first track, and then C#1 is the next. And when we have the key held, we're getting a non-zero velocity value. So now a track should be unmuted. And then when we release it, we'll get a 0 associated with that same MIDI note, and that's when we know to mute the track. So let's actually build that. So first thing, which is super simple, is just to get the device to receive those MIDI values. So this left outlet outputs the MIDI note, this right output outputs the velocity. So you can see if I hold something, 31, if I release it, 0. Then we need to basically have a little patch that goes through the live set, finds all the tracks, links those tracks, basically maps those tracks to MIDI note values, and then allows us to control this track activator, this track muter, from within the device. And the way that we're going to do that is using these special Max for Live specific objects. Live path, live object, live observer. And I'll show you a few things, show them in action, and then I'll explain how they work. So live.path is, in most cases, the first one that you're going to be using. If I say pass this message that says path live set, then live path is going to give me this ID 1. When I send it a message that looks like this, what I'm basically doing is giving live.path an address to a given object within Max and asking it to give me the ID that, I'm sorry, not an object within Max, but an object within Ableton. So I'm giving it an address of an object within Ableton and asking it to give me the ID that Ableton uses, that the Ableton associates with that object. And what is an object in Ableton? It can pretty much be anything that you see on the screen. So this dial here is an object. All of these dials are objects. This fader is an object. If I go into this track, this frequency control parameter is an object. What is also an object is this device itself, the entire device, as well as the parent track that this device is contained in, as well as the entire live set. Basically what I'm doing here is I'm asking live.path to give me the ID for the entire live set, because I know that this live set has children among which are the tracks. And that is the way that I'm going to get the live API to tell me what tracks exist in the live set. Now, how do I know this syntax? How do I know that I have to send, say, live_set? I know from the documentation. So if I go to the reference for live.path and I come over here and I click this live object model, it's going to take me to this reference document that has this crazy map on it, which is essentially the map of the live paths. And a way to think about these paths is almost like it's a map of a city, right? You have all different buildings in a city, and every location in the city, every building in the city has an address, which is indicated by a house number and a street number and a zip code and things like that. It's a similar thing. So you can identify any location within the live set using a path, and these rounded boxes are the terms that you would actually use in that path. So the one that we're using is very simple. It's just the top level here, live_set, which is the identifier of this song object. And if we click that, we can get more information about the song object. And we can see that it has children. It has a lot of children, one of which is track. And we can see that we can get and observe tracks. And this is where we get to this difference between live.object and live.observer, which are pretty similar but different in one particular way. So let's talk about how they're similar. They both take in the right inlet one of these IDs that identify an object, and they both allow us to interact with the object, particularly getting and setting information or properties of the object. In fact, I think Live Observer may not be capable of setting, so it may not be capable of, say, turning this track activator on and off, but it's capable of telling us if the track activator is on or off. Live.object is capable of both getting and setting, but Live.observer has a special advantage in that it is always watching that object, and it will let us know if there are changes. So let me just show you an example. So if I say get tracks, and I send that message to live object, because I know that I can get tracks, I've sent that message, having already passed the ID of the live set, and it's going to give me tracks and then a list of IDs, which are the IDs that Ableton Live uses to identify every single one of these tracks here in the live set. If I use Live Observer, which has a slightly different syntax, and unfortunately it's not observe, although I wish it was, you see we will get a different message. Now, if I add a track, so I've inserted a new audio track, you can see I actually now have received a new message from Live Observer that has ID 22, and I haven't gotten that from live.object because live.object isn't paying attention anymore. Live.observer is. If I hit get tracks, now it'll give me this new one. But I like this convenience, particularly for this specific situation where what we're trying to do is just get the list of all the live tracks in the set, or all the tracks in the live set, and just keep that up to date. Live.observer is kind of the one that we want right now. And what we're going to do is basically set up the device to tell us, to when it loads, basically just set all this up for us. So the first thing that we'll do, live.thisDevice, the left outlet will output a bang when the device is loaded. So we'll first say property tracks. We'll next say path live set to live.path. And if I clear this and I double click, so when the device loads, we're going to get that list of tracks. So that was pretty simple. Now we have this list of tracks, and now we need to associate that list of tracks with numbers that are going to come out of this noding object. So I want it to be so that if I send, say, 36, oops, I need to select here. If I send 36 or 37 or 38, 36 might give me ID 15, which is the sort of the first track. 37 might give me ID 3, which is the second track, and so on and so forth. And a really great way that we can do this is by using a call object. So we'll call this like call, and we'll say it's like note mapping. And we'll build a little patch that just stores the data in the call and associates each of these IDs with a number. So the first thing we'll do is create a ZL iter2, which is going to break this long list of IDs into many lists with one ID per. So there we go. You can see that printed here. And then we're going to do a TBL. And we're going to join the ID, which is coming out this L, with a integer that is produced by a counter. So that we get messages that look just like this, which stores all that data. Anytime you have a message into a call that starts with an integer and then has a bunch of other stuff, then call takes that as a command to store the stuff at the index that is that first item. So you can see here that now we have this mapping stored in the call where 0 is associated with ID 15, 1 is associated with ID 3, etc. And now if I send those values just by themselves into the inlet here of the call, I can get out the IDs. So why did I start from 0? The reason is that it's just generally easier to store things with 0, and what we can pretty easily do, knowing that we get, we're more likely to get something like 36 from a node in. Like I just loaded, I opened my push up and I just pressed the lower left-hand corner on the push and it gave me 36. It didn't give me 0, which is pretty standard for a MIDI keyboard. So what we can simply do is just add a little bit of an offset here, where we just subtract the value that comes from the MIDI keyboard from, let's say, 36 in this case. And I'm going to go over here into the inspector for the live.num box and enable initial and set that initial value to 36 so that when this device loads, it will output a 36. And then we can connect that. So now if I hit different keys, I get different IDs, and I'll connect this here. So we see we get 36, which is offset to 0, which is ID 15 in the call. Now I'm doing number 37, and so on and so forth. So now what we have the call doing is basically connecting these MIDI notes to these track identifiers, and now the last thing that we need to do is use the live.object to actually change the mute state of that track. So we're going to pass the ID that comes from the call into this right inlet. And then we're going to use the velocity that comes from the node in to mute and unmute the track. And what we want to do is see if the value that comes, the velocity value, is 0 or not. So we're going to say, is it 0? And if it is 0, we'll get a 1. And if it's not 0, we'll get a 0. So if I hold down a key, I'm going to get 0. And if I release it, I'm going to get 1, which is useful because if we go back to our documentation and we look at the track documentation, and we go past this children section and we move into this properties section. So for any given object, they have both children and I can also have properties. Children is the objects that are children of this object. The properties are the sort of attributes of the object that you can interact with. So one property of the track type of object is called mute, which is right here. And we can see that we can get, set, and observe mute. So what we actually want to do in this case is set it. So what we'll say is set mute, so that if we hold a key, we get set mute 0. If we release a key, we get set mute 1. And we can connect that to the right inlet here, so that now we press a key, it sends a MIDI note, which gets a track using this mapping, and then it either mutes or unmutes the track. However, there's one small problem, which is that live.object wants to get the ID, and then it wants to get the message setting or getting things, right? It needs to know first, well, what track am I actually looking at? The way that we have this set up right now, because the velocity output of note in is to the right of the note output, we're going to get the velocity first, and we're actually going to send this set mute command to live.object before it's looking at the correct track. So a way that we can solve that problem is simply to store this mute message and just hold on to that until we have an ID. Send the ID first, and then bang through the mute message using zlreg. So now what will happen is I'll play the MIDI note. It's either 0 or non-zero. If it's 0, we get a 1. If it's non-zero, we get a 0. That information is stored in zlreg. Then the note comes out. It interacts with the mapping. We get an ID. That ID is sent on to live.object. And then finally, at the very end of the process, we bang the zlreg and get the set mute message that we saved into live object. So now we should actually be done for the most part, and we should be able to mute and unmute tracks by pressing keys. So now I'm pressing 36, 37, 38, 39, 40, etc. Now, one thing that this does not do, and actually let me just delete a few tracks to make it easier to look at here. But if I go start back from the beginning, 6, 7, 8, actually let me delete one more. So 7, and then if I do 8, what's going on? I would like for this to be the return track. But it isn't, because if we go back to our documentation, we can see that return tracks is a separate section of the path. So if we want to include the return tracks in this system, what we're going to need to do is add another live observer, with property return tracks. And then what we'll simply do is just combine that with the list of the regular tracks. And if we now look in our call, we could see that we have 15. And if I come over here and I go 1, 2, 3, 4, 5, 6, 7, 8. Oh, something's wrong. What is it? So we have all these numbers. Here's the problem. When we did our counter, we forgot to have it reset the count anytime it gets a new list of tracks. So here's what we'll do. We'll do TLB. So whenever we get a new list, before we iterate that list, before we break it up into chunks, we're just going to send a bang to the third inlet of the counter. And for good measure, let's also just clear the call. So we're just going to, anytime we get a new list of tracks, we're just going to start fresh. We're going to bang the counter, which means that the next time it gets a bang, it's going to output 0. And then we'll also send a clear message to the call, which just erases anything that's in there. So now let's try this. And now let's look at our call. I have to close it and then reopen the window. There we go. So now we only have 9, which is hopefully correct. 7, 8, and then 9, 10. Great, cool. So there's 10 tracks, 0 to 9, and then we just use this offset thing to mute and unmute. Now, I think there's one other thing that we might want to do, which is exclude the track that contains the track muter from our thing, because, like, why would we want to mute this track that doesn't produce sound and only has one purpose, which is to do the muting and muting? It doesn't actually matter, because even if the track is muted, it still totally works. But let's do it anyway. So here's how we might do it. We're going to use live path again, and we're going to send this special message called path live this underscore device. And what this does, oops, sorry, not live device, but path live this underscore device. And that's going to give us the ID of this literal Max for Live device that is sitting in the live set. This is what's called a non-canonical path, which is a concept in Live for sort of identifying these paths to objects. And a way to explain this is to think again about a city. So if I gave you an address like 111 Main Street, Houston, Texas, and the zip code and whatever, we could call that the canonical path, right? If I use that address and I send a letter there, it's always going to go to that location. But if I said this house, right, or the house where Howard lives, that can change. It depends on where I am. It depends on where Howard lives. The canonical path of that location can be different based on who I am, who Howard is, and where I'm located and where Howard is living. So this is a non-canonical path, and it's a pretty useful way to just really quickly get the ID of this given device. What we'll then do is pass it into a live.object. Oops. We're going to do a TBL. We'll send the ID in, and then we're going to do a get canonical parent. So we're going to say, hey, first, let's find this device, and then give me the ID of the parent object, which is ID 15. And if we look on our call, we can see ID 15 appears to be this first track. And let's test it. It is. So now we know that the track where this device is located, and this, it could be over here at the end of the list, it would still give us the correct ID. And now we can just exclude that from our mapping. And there's probably a million ways you can do this, and one way that I can think of at the moment would be, oops, my keyboard's disconnected. There we go. I'll say route canonical parent. And pass this into the left inlet, and then here we'll do this. So if I just show an example, so right now we have the ZL filter has received ID 15. And if I send ID 15, or if I say send ID 2 in there, so if I send ID 2, it's going to remove anything from that input list that was in the filter list. So the symbol ID and anything else. If I send ID 15, I get nothing because ID 15 is in the list. If I said, if I said ID 15, ID 6, I'll just get 6. So what we can do basically is, and this is a little kludgy, but I think it's fine, is just stick one of these in here. Get rid of all this. Create a little space for ourselves. And now, if we print the output here, Let me get rid of some of, seems like we have other print objects in the mix here. Yes, we do. You could see ID 15 isn't there anymore. And if we look at our call, one annoying thing about call is if you double click it, it'll open the window, but if the window's already open, it won't reopen the window, and so it will show you old data if the data has since changed. So I had to close the window and then open it. But now you can see ID 15 isn't in there. And if I go back over here and I hit my lower left-hand corner, which is MIDI note 36, now I'm just muting and unmuting that second track. So that's nice. So that's basically that. I will clean this up just a little bit and add it to a link down below in the description of the video. And use the comments to let me know if you have any questions. Thanks.